Okay, ladies and gentlemen, this is how our circuit looks like. And then, as we had already said, we have a 25 amps independent source, the 20 amps independent source, the 20 volts independent source. Now, if we are to use, of course, superposition or any other principle, but let me talk about superposition. You switch off you switch off the rest of the sources and maintain the one. For example, if it is a current source, you open circuit here, you open circuit this one if you want to maintain the 20 volts. If we want to go with 20 amps, of course you also short circuit the battery source and also open circuit the other source. If we want to go with this, then you open circuit here and still short circuit. So it becomes quite a lengthy problem. But if it is not required of you to do all of that, and maybe you wanted to analyze to get the answers, you just have this and draw it in multisim like we are going to see. So I have two independent current sources. Maybe let me first go and look for an independent current source, a resistor, and a battery. At least I know I have those components. So what I do, I come here. When you check on this interface you have, when you come just around here, you'll see place basic. So place basic, that icon or that symbol looks like resistor. So it means you can get most of the components there. So let me press there. So when I press there, I'll find that what opens and here in my components that I have is resistor. But if I didn't have that resistor, I would still come back here and check on all families of these components. Let me say I had maybe something that looks like that. But so if I find that is showing me all groups, I just come here and look for the basic ones. So the basic ones that are given, we have a switch, we have a transformer, we have a capacitor, we have a resistor, an inductor, and the rest. So you choose what you want. Me, I want a resistor. So I pick a resistor, I click in the middle there. So when I click there, it takes me back to the component database. So what else do I need? I need what they call a current source or a battery, a power source, maybe, which could be a battery. So what do? I come here on basic. Again, I said you come here on basic, you look for sources. So when I click on sources, I have several of them. I have AC power. If I click on AC power, it would show me a source that has a variable or a varying voltage source or current source. But me, I want direct current. So I'll just go down here. I will go down and look for DC. Let me use DC power. DC power will help me to get the current, the voltage source. So I just click on it, go, and put it. So the moment you have it selected, when you click, it directly takes you here and you come with it. So in this environment, you just click anywhere. So that means it is already there. Then another component I need is a current source. So I need to go down here and look for a current source. So I see here there is something called DC current. So I click on this component. So when I click on that component, it shows me this is what I'm looking for. I click OK. Then I go to my environment. Maybe the other component that I did not talk about is the ground. You need to always have your ground or your reference point. So the ground the ground is very important. So let me now close. So I already have all my components. Like you can see, I have already I don't know whether they are visible. Let me maybe zoom. So I think at least here it is visible and better. So what I do, I go back to my problem that I have. The circuit begins with 25 amps, then the 4 ohms parallel, then 10 ohms. So I have this one as a 10. Maybe I'll just double click to change the value. I don't know whether I'm clear. You double click on it. You double click on it. You make sure it is selected. First of all, it is like this. Then you select. Then you double click. So when you double click, it tells you, it takes you to where the value is. Don't mind about other parameters. Just put in 10 ohms. If it is 10 ohms, put in 10 ohms and move. Remember, you have several other resistors, but those resistors, when you look at them, some are vertically arranged, others are horizontally arranged. So I have about 1, 2, 3 vertically arranged and 2 horizontally arranged. So I just come here, and maybe for me to be faster, I copy this and paste it. Okay, then I select this. I want it, maybe let me also first paste another value. So let me paste that. Now I need to flip it or rotate it so that I have it vertical. So let me rotate it through an angle of 90 degrees clockwise, so that I have it look like that. So I have about 3 of them. So what I do, I copy this and paste. I paste. You already have, you have also 2 current sources. So I need it also copy this and paste. Maybe I need to move my ground nearer. So let me put my ground here. Okay. So I just need to arrange them properly and start connecting them. So the other current source is not yet there, so let me copy it and paste it here. So also select it and double click. So it is 25 amps. Also don't look at other parameters, just put in that 25 for now. It's very sufficient. Then let's look at the other source. It is also 20 amps. And the other source is we have 20 amps and 20 volts. Okay, this is 20 amps. So I need to arrange them. So now what I do, I need to interconnect them. Let me see if I have all that I need. Okay, I have all that I need. Okay, so I just need to interconnect them. That one is done. I know the 10 ohms is connected to 25 amps, but between that connection I have a 4 ohm resistor. So I come here and move maybe this one closer. Then I come to the end of that resistor. Then you'll see that pointer coming out, and it helps you to make a connection. What else? But remember, that was a 4 ohm resistor, so I need to change this one to 4. Then what else? I had the 2 ohm resistor here, so I have a 2 ohm resistor here. Then between the 2 ohm resistor and the 10 ohm resistor around here, we have a connection of the 20 amps source. So I move it closer. I connect. Can make it move that side. I move my cursor here. I prolong it to create a connection. That one is done. So since I have nothing down there, I just connect this endpoint or this. Let me just, then I connect this. I connect that. We move. Let us see where the other, so we are remaining with the 1 ohm. So we are remaining with only 2 resistors that are not connected. So we have a 10 here and we have a 1 ohm. So we have 1 ohm there, and the 10 ohm is connected at the end of the 1 ohm. So I come here and say, I move this a little bit closer. I connect that to that. This one is not necessary, is not needed. So I also connect this to the rest of the components of the circuit. Then I have the 20 ohm, the 20 volts source, the 20 volts battery source. So I also need to connect it to the rest of the circuit. Okay, so we can check. Remember, we need to connect it to the ground. In any circuit, you always have a negative and a positive. In other words, you have an area that is of high potential and an area of low potential. Meaning, you expect current, for current to be flowing, there must be a difference in potentials. If you have 10 volts somewhere and 10 volts somewhere, then current is not going to flow. But if you have 10 volts and 2 volts somewhere, then their current is going to flow. So if we create ground as our reference point of 0 volts, then we know all this current, the currents around this circuit are going to be flowing, but in one way or the other, they will always also flow through the ground to complete the circuit, of course. But if you don't have it, you will find you have errors. Maybe we can disconnect it. We will see its importance. So what else do we need in this circuit? We need a measuring equipment, of which we have an ammeter, we have a voltmeter, we have an ohmmeter for this case of this problem that we are solving. So what you do, you come here to this extreme column. There are components for measuring. You have a multimeter. You have here a function generator is for generating a particular function. We have a wattimeter. We have a 4-channel oscilloscope. You have several, but for us we are interested in a multimeter. So we pick a multimeter and put it there. So in this problem, we are required to determine the current flowing here and the current flowing through the 2 ohm. Let us see. Yeah, we need the current flowing through the 1 ohm, the current coming from the 20 volts battery source, the current flowing through the 10 ohm. So that means we need to, and also actually the current passing through the 4 ohms. So what we do, we connect our ammeter here, our ammeter there, our ammeter there, our ammeter there, our ammeter there. When we simulate the circuit, we should be able to see the currents. So what does that mean? What you have to also remember is that an ammeter is always connected in series and a voltmeter is always connected in parallel. So if we want to measure voltage, you always measure you always connect it in parallel to that area where you want to measure that voltage. A current to be measured, you need to have current pass through the measuring equipment and coming out of the measuring equipment. So that means you need to connect it in series. So what does that mean? I'm going to connect my ammeter here. So this multimeter has has 4 parameters it is going to measure. It is going to measure amps, which is current, then volts, which is going to be potential difference, or just the volts dropped across that particular resistor. Then it can also measure ohms or resistance of the circuit. Then the decibels, we are not going to use this, but we can use 2 or 3 of these. Now, what are we going to do? If we need the current here, we are going to remove that branch and just connect our ammeter or our multimeter in series. Yes, meaning the current that is coming from here will just flow. But now, remember, you need to position your equipment. Your measuring equipment is going to be in this. You need to measure the direction. I mean, you need to measure current in the direction given. So what does that mean? This current is coming from positive going that side. So it means it is flowing from negative to positive. So if I'm to connect my voltmeter, which point is more positive than the other? So I will say this point here is positive, the other point, okay, whichever way we are going to look at it, and you will see. You can, if for example, let me say if it was coming from this side, on this resistor, you know there is always potential drop. So if you have voltage drop, you have your positive, where the current is flowing, you have a positive, and after the resistor, you have a negative. So likewise, you need to put your positive of the voltmeter here and the negative on this side, so that you now measure the positive value according to how the current is moving. So let us position our measuring equipment. So I'm going to connect. We have said, okay, maybe we are saying our positive value is going to be here. So maybe let us do it like this and connect this negative here. Much as we know there is no voltage drop across here, but it will help us when also we come to measure, for example, current here. So let us copy this and put it somewhere here. We need the current flowing through this one. So the current flowing through that, okay, let's use this point. So we are going to put our positive there and our negative there. Okay, maybe for now let's first simulate the circuit and we see our results. So for you to simulate this circuit, there is this green kind of button that shows run. When you reach there, it shows you that for you to use this button, you are going to run the circuit. So you can either press F5 on your computer, or you just come to this green button and run it. What is the problem now with this circuit? First check down here. They are saying no ground node was found in your circuit. To ensure accuracy.
Mr. Martin.
Yes, please.
Martin.
Yes, please.
May you help me, because we are receiving some reflection from Gondeze. May you tell him to unmute, please, to mute the microphone.
Oh, there is someone controlling that. I think he has heard.
Yeah. All right.
Okay, thank you. Okay, so they are saying no ground node was found in your circuit. So to ensure accurate simulation, add a ground component and simulate again. So They are saying we have 0 errors but 1 warning. So for us to have it work properly, let's connect the ground, please. So now let's run the circuit again. So you double click on this. Now what is the problem here? If you leave this with a voltage provision selected, and you have connected your voltmeter, your multimeter in series, then you're going to get wrong things. For example, now if I check on this and I put, for example, I want amps, you can see it is going to be challenging. Here you're measuring, you have connected it in series, but you have selected volts. And here you have connected it in series, you are measuring amps. You need to be consistent. If it is in series, if the component is, the equipment is in series, then it has to be an ammeter. If you are measuring volts, then you cannot connect it in series. Yes, so what you do, you select your amps. So when you select your amps, maybe let me close it again and simulate. So let me check. I have -8 here, I have 10. So if I'm taking results, I'm going to take 10 as the current passing through this 1 ohm resistor. Maybe let us go and check on our values that we had in the calculation when we used superposition principle. So you can see, using superposition principle, the current passing through the 1 ohm resistor is 10 amps. And the one that is coming from the 20 volts battery source is -8 amps. But what does that mean? Of course, this means that the current actually does not flow in that direction. The chosen direction is wrong, but instead this battery source is actually receiving power from the 25 amps and the 20 amps. So that is how you can measure current. Maybe let me go ahead and look at also how to get current in that branch. So I get my circuit, my ammeter I've selected, then I come and paste there. So remember, I need to connect it in series. Remember, current is flowing with the positive and ending with the negative. That's why I'm connecting my positive at the beginning and my negative at the end, because there is a potential drop. Okay, so if I simulate or I run the circuit, then I'm going to double click here and get the amount of current passing through the 4. If I go to my diagram here, okay, sorry, it wasn't shown, but I can maybe look for the one passing through the 10 amps, the 10 ohms resistor. So what I do, let me close this, because the purpose is to really verify yourself and see that you're on the right track. So let me get this, I connect it to before, because there is a voltage drop here, so I say it is plus, then minus. That's why I'm connecting my multimeter positive to this point and my minus, the minus of the multimeter to this point. So I run the simulation and double click here. So when I run the simulation, it shows me, okay, let me double click all of them. It shows me that actually the current passing through the 10 ohm resistor is 5 amps. The one passing through the 1 ohm resistor is 10, and the one going to the 20 volt battery source is 8 amps. So let us check with our answers here. You see we have a 5 amps passing through the 10 ohm resistor according to superposition principle. So now if they want us to calculate, for example, the voltage drop across the 4 ohm resistor. How do we do that? So maybe let me disconnect this ammeter here. Then now I want to connect it here so that now I measure voltage. So I said a voltmeter is connected in parallel to the resistor. So I said I have a positive when current is flowing across the resistor. We have a potential drop, so it will be moving with a positive and end with a minus. So I'm going to connect my positive here and my minus at the end of the resistor. That is after establishing that actually current is going to, when it reaches this branch, some current is going to flow through the 10 and some other current will flow through the 4 ohm. That's how I'm establishing my direction. But nevertheless, whichever way you consider it to be, still there should be current coming from somewhere going and entering that branch of 4 ohm resistor. So let me so what happens if, for example, I simulate? You're going to see problems now. You see that actually now the current passing through these components has reduced. You see, this was 10, this was 8, and now they have become wrong. Why? Because I connected this multimeter in parallel to the resistor, but I did not select that I'm going to do what? I'm going to measure volts. So I should just go to this volts. I remove the amps and put volts. So if I put volts, you see the simulation is still moving on and the currents readjust themselves. So it has gone back to 10 amps this side and 8 amps this side. So it means if I'm looking for the voltage drop across the 4 ohm resistor, it will be 80 volts. What if now I changed the leads or the probes? If, for example, instead I interchanged and put a minus this side and let me put the minus before and put a plus at the end. What happens? Let's run and see. You see, the result does not change, only the magnitude remains the same, but the direction has changed. So it means instead the current is moving from this direction to that direction instead of from this direction to that direction. That's why I have now a negative 80 volts. So the right way, actually you cannot make those adjustments when it is running, so that's why you need to first stop the simulation, then you go back and change the probes to their original positions. So that means I'm going to bring this one here and this one at the end. I simulate and you can see it comes back to 80 volts. Okay, so what if now I want to measure the voltage drop across the 1 ohm resistor? Still there is nothing different. I just have to get a voltmeter. I connect it here, so I know current is flowing in that direction from here to there, so I'm going to just connect it like that. So when I run, it should give me a positive answer. So you can see the voltage drop across the 1 ohm resistor is 10 volts. If at all, like I told you, by the way, you need to be consistent. If I have connected it in parallel, but I choose that I'm going to use an ammeter, everything is going to be wrong, and then it is going to disorganize you, and you design, you size your components basing on the wrong values, and the circuit will not achieve the purpose for which it is designed for. So it is imperative that you understand what you're doing by saying I've chosen, I want to measure voltage drop across that component. That means I need a voltmeter, which voltmeter is connected in parallel. So also if I'm measuring current, my ammeter I'm going to use is connected in series. Even when I'm selecting those components here in the simulation, I need to say if I'm measuring voltage, then I'm going to select this V, so that now you can see they have readjusted themselves. The circuit has adjusted and now given you the right values. So ladies and gentlemen, that's how you can do it. And if there is any question, please you can bring them, because maybe time is running out, because we had specifically prepared this for an hour. Maybe we can look at how you can measure resistance. Let me see if we can do it. We need to also demonstrate how we can measure resistance. Maybe we can use more 15 minutes and do that. So if there is no question, allow me to pause this recording.